Hey there. In the last video, we saw about relational and logical operations in Matlab. In this video, we will see plotting functions in Matlab. So if you go here and check, you can see a lot of plots that are available in Matlab. So in this video, we will be focusing more on these plots here: the line plots, area plots, bar graphs, scatter, histogram, surf, and mesh. So, let's look at each one of them. So, here I have defined two vectors. The scatter function creates a scatter plot. So, if I run this, so here we get a scatter plot. So this is the syntax. We pass the vectors which represents the x coordinate. Here x represents the x coordinates, and y here represents the y coordinates from 110 to 200. So usually we set the first input as the first input the independent vector, and the second input the dependent vector. So scatter plots these data points in the graph, and these circles represent each data point. So we call these circles markers. um, Now we can give more inputs to the scatter function. So if I add a third input, a scalar, so this scalar, this decides the size of the markers here. So when I run this again, here you can see the size of the markers have changed a lot. Now if I increase the size, now you can see bigger circles over here. So the third scalar, it you know changes the size of these markers here, and 36 is the default size of the markers. So the third scalar, it changes the size of the markers. Then we can change the color of these markers if we want. So if I type in yellow, so now you can see uh, yellow markers over here. Now if I want to change this to red, just type in red, and here you can see the marker color has changed to red. The outline of each circle has changed to red. Now if I want to fill in these circles with colors, I can just type here filled. So this fills these circles over here. So now for 8 colors, you can refer to them by their name or their abbreviations. These are those 8 colors in Matlab, and inside the parentheses you can see their abbreviations. Now if I type just R instead of red, this will still work. So you can either use either type in the full color name, or you can just type their abbreviations for coloring these plots. Now you can also specify other almost 10 million other colors with a 3 element vector of red, green, blue values. We call them RGB values. The 3 elements correspond to the fractional red, green, and blue parts of the color composition. So instead of R, if I pass a vector, say 0, uh, 0.6 and 0.7. Now mm, wait so here you can see the colors, the markers filled with these with the color that I have specified here. So one thing to note is that MATLAB should not confuse with this RGB vector with the scalar which we use to specify the size of these markers. So it's better that we first enter the size of the marker and then the RGB vector while coloring these using the RGB vector. Otherwise, it's okay if we just type the abbreviation of the color of the already defined color without specifying the marker size. But if we are using a RGB vector for this, so it's better that you first specify the size of the marker and then um, the particular RGB vector. Now inside the RGB vector, as you had seen, we have three inputs. So the first input, it represents the red part, the second input the green part, and the third input the blue part of the color composition. So if I run this, so this is the red part. Since now the values in RGB range from 0 to 1, so since this is 1 and all the others are 0, this will give me a completely red color. So if I set the second vector, the second element to be 1 and others to be 0, this sets the graph the color to green. And if I set the third element 1 and all other 0, this sets the graph to be the color of the graph to blue. And when I type some value between 0.0 and 1 between these in this vector, so I get a combination of these R, G, and B colors here. So this is how you work with a scatter function. And now to join these data points we have just created using lines or curves, we can use the plot function. So uh, so this is the syntax of plot function. So this gives us a line graph or a curve which corresponds to the data points we have plotted here. So now you can experiment. So we can also add annotations to these to the plot function here. So if I want to, specify the markers, if I want to display markers in this line graph, I can just input this command over here. So this will display markers. Now if I want to, I can also change the shape and size, the shape of these markers. So if I want a cross instead of these circles, just type X and then so enter. So this gives me cross markers instead of circles. I can change this to square if I want. So this will give me square markers. And if I can also change the style of the line. So if I want dotted line, just use a colon. So instead of a hyphen, so this will give me a dotted line. So if I want dashed line, a dashed line, so just put two hyphens beside the uh, letter S. So this will give me a dashed line with square markers. And you can also change other line specs also if you want to change the width of line. So we have the line width option here. So the default um, thickness of lines in a plot graph is 0.5. So if you want to change that to something else, say 2, you can do this with the line width option. So here you can see thicker lines when compared to the previous plot. So you can experiment with modifying other properties just like in scatter function. Uh, other than the line width, the properties that can be changed with line specification input are marker size, marker edge color, marker face color. So you can experiment by changing all these properties inside the plot function. Now, if I want to add a title to my graph, so I can just type the function title, and inside the title function, I can pass the string which defines the name of my graph. So if I put something inside the title function and enter this, so this becomes my title. And we can also define the x and y axis of these of this graph if I want. So if I say define type something here, and put this here. So this will define the x-axis and the y-axis. This is used to annotate the x-axis and y-axis here. So um, this is how you give you mark the x-axis and y-axis, and this is how you give a title to a graph in or a title to a graph or figure in MATLAB. Now we can plot multiple vectors in MATLAB. So using the hold on function. So let me just so the C we have the CLF command here. Now the CLF command, it's used to clear figures or plots already existing in the MATLAB software during runtime. So this stands for clear figure. Now I have redefined the vector y. Now vector y will contain the squares of elements in vector x, and I have defined a new vector z which contains the cubes of elements in vector x. So using the hold on function, I can now plot two curves in the same graph. So if I type plot x comma y, uh, and plot um, x comma z. Now this time MATLAB will plot two curves in a single plot. Now we can change, we can add annotations to these plot functions just like we had done here in this case. So if I want to change color, so type color, then the value or just, the abbreviation. So here too I can change color. So um, and sorry, let this be green. So yeah, so Here, just like we had seen before, we can add annotations to these individual graphs if we want. Now, we can add a legend to know which curve is what. So for that, we have the legend function. So the first string which we input inside the legend function defines the first curve, and the second input, the second string we input defines the second curve. So here I type the first curve represented x square, and the second curve represented x cube. So when I run this here, now you can see a box which defines these curves which we have plotted here. And if we want, we can change the location of this box. So if I type location and type in input the direction in which this box must be situated, so the box should be situated. So if I type, say, north east, sorry, north west, so now the box is in the northeast position. Now it will shift to northwest position. When I run this here, you can see the position of the box has shifted. So the location tag, it changes the location or the position of the legend box inside the curve. Now it can sometimes be useful to display multiple plots on the same figure window for comparison. So this can be done using the subplot function. So here, let me just, comment this and close this figure. So here I have redefined x to be a vector which contains elements between minus pi and pi, and the number of elements inside the vector is 1000. And here I have defined a um, function y1 which represents sine of x. Here I have another function y2 which represents cos of x. And this command over here, figure, this opens up a new figure for us to plot. Now we have the subplot function. The subplot function takes arguments for number of rows in the plot, number of columns of the plot, and the plot number being plotted. So if I run this here, you can see uh, two plots in the same figure. So the first, here we have created a 2 by 1 um, matrix over here. So see this see this figure as a matrix. So a 2 by 1 matrix. So like we have two rows. So each plot corresponds to each element of the matrix. So take this as a 2 by 1 matrix with two rows and one column. And here you can, this third argument, this is used to specify the plot number currently being plotted. So this is how you use the subplot function. And if I change this um, and run this again, now the plots are being plotted horizontally since I have changed the dimension of this figure which I have opened here. from 2 by 1 to 1 by 2. So this is how you and I can even change the position of these vectors if I want. So cos x will be plotted first and then sin x here. Actually, cos x will be plotted here. Sin x will be plotted first, but sin x will be plotted here, and cos x will be plotted here. So this is how you use the subplot function in MATLAB. Now it can sometimes be useful to display to visualize columns of matrix. How can you visualize the columns of a matrix? You could, of course, plot each column separately using the hold on and hold off functions, just like we had seen here. But that would be very troublesome if there were a lot of columns to visualize. So, two-dimensional 2D plotting functions, for example, plot, scatter, bar, stem, etc. They behave in the same manner as statistical functions when dealing with matrices. So these functions, they treat each columns as independent variables, and they plot each column as separate lines. So if I so when I plot this here, wait. Let me clear the figure here. Yeah. So here you can see matrix 1 minus 1 0 0 1 minus 1 1 0 1. So the first line over here, this plots the first column of the um, matrix M here. So the values in these columns are represented using the values in y-axis. So here we have 1, minus 1 here, and again it goes to 0. Now the second column 2, um, 0, 1 and minus 1. So 0, 1 and minus 1. And the third column here, 1, 0 and 1. So this is how MATLAB plots matrices in matrices. So if you want the rows to be plotted instead of columns, just add a the transpose operator over here. So now when I run this, MATLAB plots rows instead of columns. So this is how MATLAB plots matrices. So in 2D plotting, we define the x coordinates and y coordinates, and MATLAB generates data points. Now, and MATLAB connects these points. Now let's look at the three-dimensional version of the plot function, which is called the plot tree function. So if I just add 3 and run this again, oh, oh, so if I so if I am going to use the data here and plot a 3D graph. So first let me edit the data here. So and this time let me use the plot tree function x, y and z. So and let's look what. So this time MATLAB creates a 3D vector, a 3D graph, as you can see here. So if I open this in a separate window over here, so um, now this is the um, plot created. So as you can see, this creates a 3D plot. So plot 3 creates a 3D line, a 3D curve of the value of the data points. And if I type scatter tree, it creates a 3D scatter graph of these data points. Now we have the patch function. The patch function is used to generate polygons. So if I clear the figure and run this over here, so you can see the patch function. The patch function here I have entered the vertices of a triangle, and using the patch function I have plotted a triangle over here. And if I want to view this in 3D, I can use the function view of 3. So when I use this here, I get a 3D view of the triangle I have plotted. So the patch function is used to generate polygons, and you can um, generate 3D polygons by adding an extra line of command over here. Now we have the mesh and mesh grid functions. So um, so let's see what mesh and mesh grid functions are. So when I hit enter here, as you can see, Q is a 1 by 3 matrix of three elements, 1, 2, 3, and W is the one is a 1 by 6 matrix, 1 by 6 vector of elements 1 to 6. Now what mesh grid does is that mesh grid function scales these elements. So here you can see that the mesh grid function scales the first vector of dimension 1 by 3 to a matrix of 6 by 3, and the second vector again to a matrix of 6 by 3. So the mesh grid function is used to scale data points before using the mesh function. Now the mesh function and the surf function. The mesh function and the surf function, they are used to create surface plots in Matlab. So we will see that here. So if I clear the figure and run this command over here, see, now here we have a beautiful mesh function. So this is how you create a mesh function. So first we will have two vectors. We will scale these two vectors using the mesh function, mesh grid function, and we will have a third input, a third vector, which is some function of the first and second vectors, and we use the mesh function to plot these three vectors x, y, and z. So if I change this equation over here to say some sign to this, so I will get another really fancy vector over here. So now we have the now if you look here, this looks like a fishing net. This graph, this figure represents a fishing net. Now the surf function looks something like this. So when I do this here, now you Matlab fills in the gaps, the spaces between the lines uh, with colors. So this is the serve function, and you can remove these lines if you want. So that we have for that we have the shading option. So if I type shading and enter interrupt, so this clears all those black lines over there. So this is how you use you clear all those lines in the serve function. Then we have the color color bar option. The color bar option, it displays a color bar which tells us what color represents which value. And we have the color map function which changes the color of this surf function. So here we have uh, you know different types of color scheme. So if I type prism here, so this will give me a new figure with a new color map. So if I type something else, for example cool here, so this will give me another another graph with a different color scheme for the values being represented. So these were the 3D functions, 3D plotting functions in MATLAB. So we saw the scatter function, the plot function, the subplot function. Then we saw how we can plot matrices in MATLAB. Then we saw the patch function, the mesh grid function, mesh and shrug function, which are used for 3D plotting. Now you can experiment more with these functions over here. So if you go to MATLAB documentation and search for these functions. For example, if I type in surf and enter, so here you can see the documentation for these functions, and you can explore more about these functions here, experiment with them using the description and details given here in this documentation of these functions. So that's it in this video. In the next video we will be seeing the conditional statements and loop in MATLAB. Thanks for watching. Bye.